Hello everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we are solving a numerical on fixed bias technique of JFET. The theoretical portion of that we already discussed in our last class. You can check from the description or you can also check it from the link after the video. So, this is the question asked in Engineering Service Prelims exam of 2021. So, ESE 3 2021. You can check it online also. So this is the circuit. The circuit given below is fixed biasing of N-channel JFET. The pinch-off voltages and maximum drain to source current is minus 8 volt and 10 milliampere. So given Vp is given as minus 8 volt, pinch-off voltage is minus 8 volt and maximum drain to source saturation current, it means IDSS. IDSS is given at 10 milliampere. Okay, these are given. So respectively, what are the values of VGSQ, VGS and IDC? IDS it is, okay? IDS, what are the value of drain source current, okay? So we have to see that in finding the value of current, we use the Shockley current equation. What is the value of Shockley current equation? ID, which is drain to source, is nothing but IDSS 1 minus VGS upon VP's whole square. Okay, here VP is given, VGSQ we have to find and IDS we have to find. So this VGSQ is already mentioned from circuit. We can see that this is our VGG. So VGSQ we can see that it is minus 4 volt. We know that this 2 ohm resistor is the voltage drop across this 2 ohm resistor is not valid because IG current is 0. If IG current, gate current is 0 because of very high input impedance. So no voltage across this resistors we have found. So we can neglect this resistor and we directly make this short circuited. So this is the value of VGSQ minus 4 volt. Okay, positive to negative here it is connected in this manner. So this is minus 4 volt. So we have to put the values. So IDS is nothing but IDSS which is given as 10 milliampere minus 1 minus IGS is 10, 1 minus VGS is given as minus 4 volt upon this VP is minus 8 volt whole square. Okay. So if we further solve, what we will get? IDS is nothing but 10, 1 minus, this is 1 upon 2 whole square. And if we further solve this, it will become 1 upon 2 whole square. We can directly write it 10 by 4, which is nothing but 2.5 milliampere. Okay. So two values we have to, we are finding, one is VGSQ and one is IDS. This is not C, this is S, okay, drain to source. So IDS is nothing but 2.5 milliampere and VGSQ is already seen from the circuit is minus 4 volt. So this is our minus 4 volt and this is our 2.5 milliampere, okay. So I hope this question you are understanding very well. And if the theoretical aspect of this numerical you have to see, you have to go to the lecture 41 of this series. Thank you so much.